Hello, folks, and welcome to the first lecture of Venn Diagram 1 revision. The quiz of this was already uploaded on the website. If you have not attended that, attempt that before watching this lecture. So let's begin and understand what Venn Diagram 1 is, understand these sets, and learn and revise a few concepts through the means of these sets. Okay, so let's start with set number 1. 15 students, A through O, in a class wrote exams in three subjects: mathematics, physics, and chemistry. However, each student failed in at least one subject. The following information is known about the number of students that failed the exams. Okay. So, what is to learn in this set? So, usually we try to make a positive Venn diagram, right? People who have passed, people who were selected, so on and so forth. This is a classic example where we should and we will use a negative Venn. What does negative Venn mean? In this, we will make the Venn diagram of the students who failed in a specific subject. And that will make everything easier for us. So let's do it. Let's just read the questions and start solving. So we have been given a couple of clues and there are four questions. Okay, I can only see a physics or chemistry in question number three. Rest of it seems pretty straightforward and solvable. So let's look at it. Let's solve it. What does clue number one tell me? The number of students who passed only in mathematics and physics. Okay, so let's first make our Venn diagram. As we said, we will be making a diagram of students who have failed. Okay. Do we have any other information? Yes, there's one more information. Each student failed in at least one subject. What does this tell us? That if we are making a Venn diagram of people who have failed, the number outside the Venn diagram will be zero because everyone has failed at least one subject. Okay. Cool, 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 cool. Let's make our diagram. Please pardon my drawing. So this is mathematics, this is physics, and this is chemistry. Okay. Let's take a few variables A, B, C, D, E, F, and G. Okay. The outside variable we know is 0 because we established that nobody has passed all the three subjects. Okay. So clue number one tells me the number of students who passed only in mathematics and physics. So people who passed only in mathematics and physics, that means they failed only in chemistry. So I'm talking about variable C. Okay. Is the same as number of students who passed only in chemistry. That means they failed in mathematics and physics. So variable D. That means I know C is equal to D. Okay, cool. Number of students who passed in mathematics is 10. So we know total number of students was 15. If the ones who have passed in mathematics is 10, that means the one who have failed in mathematics is 5, right? So this is going to be a 5. Okay, cool. And B plus C plus F is B plus C plus F is going to be 10, right? And from this logic itself, A plus D plus E plus G is equal to be 5. Cool. Very simple. Now, what does the rest of the statement say? Same as the number of students who passed only in chemistry. This was done. Yeah. K and O failed only in mathematics. So, K and O failed only in mathematics. So, we know that A definitely has K and O as its part, right? We don't know whether they are the only ones who have failed in mathematics, but K and O have definitely failed only in mathematics. Okay. Whereas A, D, and F failed in all three subjects. So we know G is going to have A, D, and F as its part. Again, we have not been told whether A, D, and F are the only ones who have failed in all the three subjects. Okay. So far what we know is A is going to be greater than equal to 2 and G is going to be greater than equal to 3. I hope everybody agrees. Yes. Cool. What does the last clue tell me? The number of students who failed only in physics are only B, E, G, and H. That means I have been clearly told that B is equal to 4 and that includes B, E, G, and H. Okay, great. What else can we derive? Now guys, what we figured out here was A plus D plus E plus G is equal to 5. A is greater than equal to 2 and G is greater than equal to 3. So these three equations will only hold when A and G take their own minimum values, right? So A has to be 2, and G has to be 3, correct? Which tells me that D and E are going to be 0. So D will be 0, E will be 0, G will be 3, and we have figured out A, D, and F are part of the D clan, okay? And A is going to be 2, where K and O are part of its subgroup, okay? Similarly, B we know is going to be 4, and B, E, G, H are its part. Since we know C are equal to D and DF is 0, we figured that out. So C is also going to be 0, leaving F to be 6. And those who are not a part of A, G, and B are going to be part of F, since all the 3 other variables are 0. Right? So this solves the Venn diagram for us. So we know P is going to be 13 people and C is going to be 9 people. I hope this is correct. Yes. And that's it. Our Venn is solved. Very simple. Because we have taken a negative Venn. The same also could have been done with positive Venn. I'm not saying no, but negative Venn definitely makes it easier because you are already figuring out the failed people, right? And the clues are also sort of a mix of fail and pass. All right. So let's come to the questions. So this is what we figured out. The diagram which you can see on the screen is what we just solved above, right? Question number 1. Which of the following is the highest? Number of students who failed only in physics or only in mathematics, which is 6. Okay. Number of students who failed in maths or chemistry. So if they failed in maths or chemistry, that means they've uh, only passed in physics, right? So apart from people who have only passed in physics, I will take all of them. So this will be 11 because we know total people over 15, right? The number of students who failed only in chemistry and physics, only in chemistry and physics is 9. Sorry, 6. Only chemistry physics is 6. Okay. Number of students who failed in exactly one subject is also 6. So therefore, clearly my answer is option B. Number of students who have failed in mathematics and chemistry. Okay. Question number 2. Which of the following option represents the complete set of subjects in which J failed? Now, J clearly is a part of the 6 who have failed only physics and chemistry. So my answer is option C, physics and chemistry. In which subject did the maximum number of students fail? So we've already figured that out. Physics, 13 students failed. So that is also very clear. So guys, if you see, these options and questions also give you a hint that a negative Venn would be better. Because all the options are failed, questions are related to students who are failing. So always keep this in mind. You don't always have to go with a positive Venn. You can go with a negative Venn. Okay. Last question. How many students failed in mathematics or chemistry? We've already figured that out. It is 11. And that's it. Set number 1 was a pretty simple set, I believe. Not more than a 6 to 7 minute set if done properly. The only learning here or the trick per se was the negative Venn. I hope this is clear. Let's move on to set number 2. All right. At National Institution of Management, Ahmedabad, there are 3 prominent clubs: Finance Club, Marketing Club, and Consulting Club. Faculty members surveyed the students of a section to find out which of these clubs they were members of. Following pointers were noted. So I have a couple of clues, and then I have 6 questions in this. Okay. Definitely a high ROI set, right? So again, this is another question which, for the sake of our discussion, I'll be solving through the positive Venn. But trust me, this is another set which you can try with negative Venn. And how do I know that? Because if you look at the clues, 3 clues or the bottom 3 clues are telling me so many students were not member of this club and that club. So when I have even the first clue, 12 students were not members of any of these clubs. So when I have so much not in the clues itself, this set can very well be done with negative Venn also compared to the previous one, right? So even though I will do it with positive for now, please do try this with negative. I hope this will be easier with that. Okay. Let's start making a couple of diagrams and let's see how this works out. Okay. So I will have my 3 sets: Finance Club. What's the approach? Okay. Marketing Club and Consulting Club. Okay. And I will have A, B, C, D, E, F, G and H. Okay. This is what I know. And since this is a positive Venn, right? Clue number 2 tells me no student was member of all three clubs. That means G is equal to 0 very clearly. Okay. And 12 students were of the section but not members of any club. So H becomes 12. Okay, very straightforward. Clue number 3 tells me in all 28 students were not members of the Beta Finance Club. So I get B plus C plus F is equal to 28. Okay. Are you sure? Understand and always remember this. This also is a part of people who are not a part of that club. So it's either B plus C plus F plus H equal to 28 or B plus C plus F is equal to 16, which is 28 minus 12. Okay. 31 students were not members of the marketing club. So marketing club A plus E plus C. Okay. 31 minus 12, 19. And 37 students were not members of the consulting club. So A plus B plus D is equal to 37 minus 12, which is 25. Okay. This is what I know. Correct. Do I have any other data? Do I have any other data? No, that's it. That's it, right? Okay. Perfect. So that's all I can figure out for now. Let's move forward and look at the questions. Okay. Question number 1. If 25 students belong to exactly one club. Okay. So we figured out the equations that we derived above, right? Now, if I add all three equations, this is what I will get. Okay. So this is also been mentioned over here. Now, if 25 students belong to exactly one club, exactly one is A plus B plus C. So if A plus B plus C is 25, right? If A plus B plus C is 25, D plus E plus F becomes 10, correct? 25 into 250. And if I take it this side, it will become 10. Okay. All right. What have I been told? The number of students who are members of the Beta Finance Club. So Beta Finance Club is A plus D plus E, right? A plus D plus E. Okay. A, D, and E. Okay. So if I look at these two equations where I know A plus C plus E is 19 and A plus B plus D is 25. If I add these two equations, I will get A plus D plus E, which is my finance club members, right? A, D, and E plus A plus B plus C is equal to 25 plus 19. I already know that A plus B plus C is 25. That is given to me in the question. So A plus D plus E becomes 19. Pretty straightforward. This is question number 1. Okay, great. Let's look at the other questions. Why am I raising this? Because that data of A plus B plus C being 25 was only relevant for this specific question. Please remember not to take forward any data from any other question to any other question unless specified. Okay. So, question number 2. If the number of students in the section is maximum possible. Okay. Now, guys, when will the students be maximum possible? If I look at this equation, if I want the numbers to be as high as possible, can I assume A plus B plus C is 0? Only then I will get maximum possible students. Correct? Because if A plus B plus C have any value, the total students, that is A plus B plus C plus D plus E plus F, will go down because that's multiplied by 2. Yes. So here that means A plus B plus C is 0 and D plus E plus F becomes 60. Very simple. The number of students who are members of both marketing as well as consulting club is what? Acha. I have been given A plus B plus C is 0. So F becomes 16, E becomes 19, and D becomes 25. What is asked? Marketing and consulting F, which is 16. Question over. Very straightforward. I hope. Yes. Question number 3. If the ratio of number of students in the beta finance club only, which is A, is to marketing only, which is B, is to consulting only, which is C, is 3 is to 2 is to 5. Okay. And the number of students who are members of more than one club is not 0. Okay. So D plus E plus F is not 0. That is what it means. Okay. The minimum number of students who are members of the marketing club as well as the consulting club. Okay. So marketing and consulting is F. Okay. Let's look at this equation. B plus C plus F is equal to 16. And I want the minimum value of F. Correct? Absolutely. Now B and C I know are of the form 2x and 5x. Okay, some constant I can multiply. So I will get them to be total as 7x. Now very clearly guys, if B plus C is a 7x and F has to be minimum, x has to be 2. So that B plus C become 14 and F becomes 2. And that's it. Question over. I hope this was clear. B plus C is a 7x form. If I have to minimize F, I will maximize B plus C, which will maximum go up to 14. So that F remains positive, obviously. And in that case, I will get F equal to 2. Very straightforward. Done. Okay, I hope everybody is with me up till this point. Let's move on to the next set of questions in this set. Remember, it's a long set. There are 6 questions. Yes. If the number of students in the section is minimum possible. Now, guys, similar logic. Minimum possible, when will it happen? When my D plus E plus F is 0. Yes, because then A plus B plus C will be as high as possible, thereby minimizing my overall sum, right? So D plus E plus F becomes 0 and A plus B plus C becomes 30. This is when my students in the section are minimum possible, okay? The absolute difference between the number of students who are members of only beta finance, okay, which is A, and consulting, which is C. So I want mod of A minus C, correct? Absolutely. So can I just take these two equations, first and third? So I have B plus C plus F is 16, okay? And A plus B plus D is 25. Since D plus E plus F is 0, all of them have to be 0 because all the numbers are only positive or zeros, right? So these two become 0. Now when I subtract this equation, I get A minus C equal to 9. And that's my answer. As simple as that. Just the same equations. We have to use them smartly here and there, and that's it. Okay. All right. Next question. What does it tell me? Maximum possible number of students in the section is what? We've already discussed this. Very straightforward. For maximum, I have to take A plus B plus C as 0. So D plus E plus F becomes 60. But don't fall for that trap. Don't forget the H. Guys, that H is the cause of half of you losing marks because you forget that there is an H outside. Right? So the number of students will be 60, which is D plus E plus F, plus 12, which is 72. Next question is about minimum. Same. D plus E plus F becomes 0 because I want to minimize the number over there. So I will have to maximize the equation which is there in the bracket, which is multiplied with 2. Yes. So here I will have A plus B plus C is 30. Again, don't forget the H. 30 plus 12 will give me 42 and my set is over. Slightly lengthy through the number of questions, but still I feel this was a very much doable within 10 to 12 minutes, as I said. Okay. Do try this with negative when. Trust me, you will like that method. And I am pretty sure that half of these questions can be done faster with that method. Do try it. Okay. Let's move on to the next set. Now, this looks like a longer set. What I believe here is if it were not in the Venn diagram quiz, one of the biggest challenges would have been to actually figure that this is a Venn set, right? Let's read it together. Kiran, an eccentric billionaire, hired 3 private investigators, Sherlock, Feluda, and Hercule, okay, and independently asked each of them to track the activities of the other 2 PIs, okay, during the same period for exactly n days. Now, as part of their respective assignments, Kiran asked each of them to record the number of days that each of the other two PIs sent any email. ठीक है? After n days, each of the three PIs provided their respective reports, which included information only about the other two PIs. Guys, this line is very, very important now. That the report included information only about the other two PIs. So if Sherlock tells me that on a specific day, only Feluda sent out a mail. That means the variables that we will consider is only Feluda and Sherlock. Right? That's the second tricky part over here. That if they are reporting only about the others, please remember to include that specific PI as well, that is per private investigator, when you are writing the equation. Don't forget that. That is, I think, one of the key mistakes one can make in this set. Okay. So after the end days, provided the respective reports, okay. And then we have a couple of clues. And I've been given a simple cautionary rule over here that during the end days, the three PIs sent emails only to each other and not to anyone else. And on any day, each PI sent at most one email. Further, the three PIs did not receive any email from anyone else apart from the other two PIs during these days. So just essentially isolating this universe that there is no other sender receiver outside these three PIs, and also telling us that there is only one mail on one day that one PI sends. So that again we don't get confused with the number of mails, so on and so forth. Very simple. Let's look at the clues and try to answer the questions. Again, here 5 questions are there. So the ROI seems better, right? So let's answer the questions. Okay. All right. So I have Sherlock, I have Feluda, and I have Hercule. Okay. ठीक है. First, of course, I can go through all the points. So according to Sherlock, there is something. According to Feluda, there is something. And according to Hercule, there is something. I'm sure all of these will give me equations. So let's just write this. Never forget the H. Okay. Okay. What is the last point? Tell me. At least one of the three persons sent an email on each of these end days. By the way, this when is about who sent an email on which day, how many days. Okay. So if I've been told that at least one of them sent an email on every day, that simply means H becomes 0. Very simple, very straightforward. Okay. Now let's try to figure out these other clues. Clue number 1 tells me, according to Sherlock's report, the number of days on which both the other two PIs sent an email was 50. Both the other two PIs. So it can be intersection of F and H, which is the small f. And it can also be all three because Sherlock is not including himself in this report. So F plus E is equal to 50. Okay. While the number of days on which only Feluda sent emails was 34. So again, similarly, B plus C becomes 34. Okay. According to Feluda's report, the number of days on which only Hercule sent emails was 34. So only Hercule, according to Feluda's report. So G plus F is equal to 34. Okay. While the number of days on which only Sherlock sent emails was 27. So A plus B is equal to 27. I hope this is straightforward. Yes. Third clue tells me, according to Hercule's report, the number of days on which both of these other two PIs sent an email was 43. So B plus E is equal to 43. Okay. While the number of days on which only Sherlock sent emails was 29. So A plus D is equal to 29. Okay. And the number of days on which none of the other two PIs sent an email was 21. This is the clue which cracks the case. Because we know H is equal to 0, and if Hercule is telling me that the other two PIs have not sent mail on 21 days, that means we know G is equal to 21. Because only Hercule is sending on that day. We know every day a mail has been sent out, right? And now once I plug G equal to 21, all of these equations will get cracked. I get F from this equation. I can put F here, I get E, so on and so forth. I will get all the values. I will leave that to you. Let's move on to the questions. Okay. So this is the numbers that I will get. On any day that Sherlock received an email, question number 1, On any day Sherlock received an email, Hercule sent email to Feluda. So if Sherlock is receiving and Hercule is sending to Feluda, that means Sherlock is receiving from Feluda. Okay. That means I know for sure that Hercule has also sent, number one, and Feluda has also sent, number two. Okay. What I don't know if whether Sherlock has sent or not. Sherlock could have sent, could not have sent. Yes. So now I have to count the days when Sherlock has sent, having known that Hercule and Feluda are definitely sending, and the number of days Sherlock has not sent when Hercule and Feluda are sending. Very simply, this is the number, which is 50. That's it. Question number one is done. Okay, this will be 50. Question number two. It is known that Sherlock received an email. If Sherlock received an email on any day, Feluda also received an email on that day. Okay. But we have no information about the senders. So it's possible that Sherlock and Feluda were sending to each other, right? It was possible that all three of them were sending to each other, correct? So we don't know. It could be possible that, Sherlock is sending to Feluda, but Hercule is sending to Sherlock. So we know minimum two emails are being sent, and we know maximum three emails are being sent, but we don't know which one. So very simply, all I need to do in this question is to add all the values where minimum two emails are being sent. And that is 64. And that's it. That is my answer. I hope very straightforward. Yes. Question number 3. What is the minimum number of consecutive days during the given period on which Hercule could have sent an email? There is no constraint. 79 are there. We have no constraint about consecutiveness and, spacing them out. It's just 79. Simple. On how many days during the given period did Hercule send emails but Feluda did not? So Hercule sent, Feluda did not. Right? So this is the part. We all know basics of when. Within the circle of Hercule, outside the circle of Feluda, that will be my answer. 29. Okay. Last question. What is the value of n? N is nothing but the number of days on which they have sent emails. And that is nothing but the addition of all the numbers in this Venn diagram within the diagram. Yes. Since h was 0, we don't forget h. This will be equal to 134. And that's it. Set number 3 also over. So as I said, I believe the most tricky part in this set was to identify that it's a Venn diagram set. And once that was done, just going through the 3 clues one by one, making equations properly, and then plugging the value of G to get 21 and all the other values. It was again a very simple set, in my opinion. 10 minutes maximum you should have taken if you were able to identify it's a Venn diagram set. Okay. Let's move on to the next set. Okay, interesting. 25 classmates of 2001 batch are of class X are members of at least one of the 3 WhatsApp groups. Again, so here I'm going to make a diagram of how many people are, members of which group or how many groups. I've already been told they're members of at least one of the 3 groups. So what do we know? H is going to be 0. Remember that. Okay. The names of the groups are Chat Lounge, Just Talk, and Chaos. The number of classmates who are members of all the 3 groups is less than 6. I think this is what makes this set interesting. That we have not been given equal to's a lot. We've been given less than, more than, and inequalities. So let's see how to deal with inequalities in Venn diagram. That's the whole idea behind discussing this set in revision. Okay. So let's make our diagram quickly. Please pardon my drawing. I know it's not that good. So let's say I have Chat Lounge, I have Just Talk, and I have Chaos, right? That's the numbers I've taken. Yes. A, B, C, D, E, F, and G. And we already know H is 0. So I'll not take H. Okay. Now, what do I have? The number of classmates who are members of all the 3 groups is less than 6. So I know E is less than 6. Okay. Number of classmates who are not members of Chaos is less than 11. Not members of Chaos. So A plus B plus C is less than 11. By the way, guys, I hope you remember total is 25. 25 classmates are in discussion. Okay? the number of classmates who are members of only one group is more than 16. So A plus C plus G is more than 16. ठीक है? Okay. The number of classmates who are members of at least two groups is more than 7. So at least 2 is exactly 2 plus exactly 3. Okay. Okay. The number of classmates who are member of all three groups is more than the number of classmates who are members of exactly two groups. So I know E is greater than B plus D plus F. Okay. Amazing. So this is the information that I have. Let's see what we can make with this. Okay. Since I know E is less than 6, right? E can have values like 3, 4, 5. Okay. Let's can also be 1, 2 for all I care. Okay. Now, since I know that E is greater than B plus D plus F and B plus E plus D plus E plus F is greater than 7, E has to be at least 4, right? E has to be 4 minimum. So if E is 4, B plus D plus F, let's see. Let's just take cases. If E is 3, if E is 3, B plus D plus F can maximum be 2, and this sum is less than 7, so this is not possible. If E is 4, these can be maximum 3, right? Because E is greater than B plus D plus F. But again, the sum of those is not greater than 7. So I know for a fact that E is equal to 5. I hope that is established. Yes. So let's just remove this. Okay. And I know that E is equal to 5. Okay. This is what we know. Now, guys, if I add A plus C plus G on both sides of this equation, right? A plus C plus G, if I add over here and I add A plus C plus G, okay? This part becomes 25, this part. So 25 is less than 7 plus A plus C plus G. And if I take the 7 over here, A plus C plus G becomes less than 18. So therefore, I am able to establish that A plus C plus G is equal to 17, right? So I know this. I know B plus D plus F ranges more than 2. And I know A plus B plus C is less than 11. What else can I do? What else can I do over here? Mm, can I get some other values? No, I think that's it. So let's move forward. Let's see. Yes. Cool. Just give me a second. So if A plus C plus G is 17, I know E was 5. So B plus D plus F becomes 3. Yes, I can establish that as well. Okay. Now let's move forward. Okay. How many classmates are members of all three groups? We've already established that it's 5, right? How many classmates are members of chaos? Chaos is 5 plus D plus F plus G. Now D plus F plus G, we have a limit, but we cannot say for sure, so cannot be determined. How many classmates are members of only one group? So A plus C plus G, we figured that to be 17. Very simple. Now we have an additional information. The number of classmates who are members of two groups, Chat Lounge and Chaos, is equal to the number of classmates. So Chat Lounge and Chaos is D plus 5 is equal to the number of classmates who are members of two groups. Um, Just Talk and Chaos, which is F plus 5, which is 6, right? So D becomes 1, F becomes 1, and we know B plus D plus F was 3. So B also becomes 1. Yes. ठीक है. All right. The number of classmates who are members of exactly two groups, which is 3, is equal to the number of members of Chat Lounge group alone. So this becomes 3. Correct? Very good. So what is the sum of number of members of the group Chaos alone and Just Talk alone? So if A is 3 and I know A plus G plus G, A plus C plus G is 17, this becomes 14 and this set is solved, right? So you had to deal with inequalities a little carefully, of course, and you have to find where what limits can be set for minimum maximum, right? If all the inequalities over here, let's say, if all the inequalities were just say lesser or just greater, then maybe this set would have been tougher because then we would actually be playing into ranges. But because the clues gave us a mix of greater than and less than kind of conditions, I knew that if we are able to add and subtract a few elements, we will be able to get exact values as much as possible. Okay. So let's move on to our last set. In a school, okay, this is a classic maxima-minima set. So if this concept is not clear to you, pay careful attention. Okay. In a school, all children have to take coaching for at least one sport among football, cricket, and hockey. At least one sport. So again, I know H is equal to 0 if I take the Venn diagram as people who take coaching for football, cricket, hockey, and combinations. Okay. Among 90 students, so the total is 90, it was found that the total number of students taking coaching for football is more than that. Okay, so I have a few clues and then I have 4 questions about minima maxima. Let's go about making a certain conditions that we can, and then we'll take one question at a time. Okay. In a school, all children have to take coaching for at least one sport. We've established that. It was found that the number of students taking coaching for football is more than that for cricket. So let's just make our diagram. Football, cricket, hockey, A, B, C, D, E, F, G. We know H is equal to 0. Okay. Football is greater than cricket. So football is nothing but A plus B plus D plus E is greater than cricket, which is C plus B plus F plus E, which is greater than hockey, which is G plus D plus F plus E. Okay. All right. It was also found that this number of students who take coaching for exactly one sport, which is A plus C plus G, is greater than two sports. So B plus D plus F is greater than E. Yes. Okay. It is also known that the number of students attending coaching for hockey is G plus D plus F plus E, is greater than those attending coaching for exactly one sport, which is A plus C plus G. So essentially what I get to see is this whole inequality is greater than this whole inequality. So it's just one large inequality. Also focus, guys, we have not been given any constraints of what is minimum value of E, can it be 0 or not, right? We don't have any constraints on whether any of the other variables have to be 1 or anything like that. We just know that the total is 90. Okay. That's all we can figure out from the given clues. We'll have to move question wise now. Okay. All right. So what I've done is I've clubbed question number 1 and 4 because they were talking about a specific sport. And then we'll go to the other 2 questions. Okay. Question number 1. What is the maximum number of students who attended coaching for football? Okay. Now we know total is 90. Okay. This is one part and this is one part. Right. This is my whole inequality. Now, guys, when I'm looking at football, I have to maximize the sum, this whole sum, right? A plus B plus D plus E. Now, if I have to maximize the whole thing, I'll try to maximize each element one by one, right? And in order to do that, I'll start with the innermost element E. You can start from anywhere. This is just a process that I like to follow. So, if I know, guys, that the sum of all of these variables is 90, and I know A plus C plus G is greater than B plus D plus F is greater than E, what is the maximum value E can take? So for that, very simply, I can divide 90 by 3, and that will give me 30 for B plus D plus F and minus 1 plus 1 for E and the other equation. So this way, I'm able to divide the 90 in only one sport, only two sports, and all the three sports while maximizing the value of E. Why am I doing this? I want to maximize the overall football count. Okay. Cool. Now, once this is done, I know that E is 29. Okay. Now I have to maximize B plus D. As I already mentioned, there is no constraint of whether any variable can be F or not. So I can give all of these 30 B plus D plus F to B plus D and assume that D is F is 0. Yes. So I can just take this as, let's say, 29 and F as 0, right? And I can take B plus D as 30. Again, I can distribute it anyway between B and D. But can I do 15-15? No. Because if I do that, then cricket and hockey total number of players will become equal. Yes. If I before I move on to the rest of the variables. So for the safety sake, I will keep this as 16 and this as 14. Right? Now, if I see my cricket is more than hockey is fulfilled. My football is greater than cricket is fulfilled. My one sport, two sport, three sport is also fulfilled. So theoretically, I can give all the 31 players to only football. Yes. And therefore, the answer for this question will be 90. All of them can play football. Right? Again, why am I doing this? How was I able to give 31 to A? Very simply, because we have no constraints on the variables. I have fulfilled all the inequalities that I have. And so, in an extreme example, to find a maximum, I can give all 31 students to A. Okay. Another simpler way to look at this was, of course, that I can just see that I will be able to distribute all the students in a way that only one, only two, and only three sports constraint will be taken care of. Right. So even without doing all of this, you could have given the answer 90 if you have that conceptual understanding of how maxima-minima in this works. And why was I able to do that even without solving? Is because football is the highest. You can't apply that logic to the other two, just directly like this. Okay. So just giving a tip that if in this scenario, this kind of a scenario, we can directly give 90 to football while being able to adjust it for other variables. Okay. Next question. What is the maximum number of students who attended coaching for hockey? Okay. So let's look at that. Now, when I'm looking at hockey, I have uh, G plus D plus F plus E, correct? G plus D plus F plus E. Again, I have to maximize this. So I'll start with one variable. We've already found the maximum value of E to be 29. Okay. Let's just remove this. Okay. Now, next, among B, D, and F, I have 30. And I want to maximize hockey. So one is I can just give DNF to hockey and then move forward from there, ensuring the other constraints of the football, cricket, hockey are taken care of. But another way that I can simply do is for now, let's just distribute B, D, and F because I need to find the maximum value of hockey players while ensuring that the number is still minimum between cricket and football. Okay, so that's the slightly tricky part. So let's look at this. So I know football has to be greater than cricket has to be greater than hockey. Okay, great. Now since I given 29 to E, 29 is for all three sports. So 29, 29, 29. This is done. Now this 34 now I am distributing among all the sports. You can give it to only hockey. Doesn't matter. It will take care of itself. Okay. For now I'm distributing among all B, D and F. So B becomes 10, D becomes 10, F becomes 10. So therefore to each of them we will add 20. Okay. This part is clear. So I get 49, 49 and 49. Okay. And now I'm left with 31 to distribute. Now 31 again, why I'm equating and trying to distribute them like this? Because I want that the football players, cricket players and hockey players are as close as possible. Only then I can have hockey as maximum. Right? Because if football, cricket are further away, the number will only come out of hockey. And I want hockey to be maximum. Okay. So I'm trying to keep them equal till the last point. Now I have to distribute 31 between A, C, and G. And if you see A, C, and G are the variables representing only football, only cricket, and only hockey. So now these 31 students will be distributed only among single sports. So to begin with, when I completely distribute them equally, I can add 10 more to this, each of the sports. Okay. So I get 59, 59, and 59. And I'm left with one more student to distribute. Don't forget that, one more student. Okay. I hope everybody's with me. How this 59 is coming when, sir, the total number of students were 90. Total students is including overlaps. Okay. So these are the students playing all three. These are the students playing two sports. And now we are distributing the students playing one sport. So this is a technique which I've taught in the lectures as well, right? Equate, distribute, check inequality, and adjust. This framework we have covered very well in our lecture. So now this one which is remaining, I will give to football for now, okay? Which will give me a 60 over here. So I've distributed all the students, but there's one inequality which is still not proper, which is cricket and hockey, right? So if I give one from hockey to cricket, then football and cricket will become equal. Again, that is not okay. So therefore, I will have to remove one from hockey and give it to football, thereby getting football as 61, cricket as 59, and hockey as 58. So hockey's maximum value, while being minimum among the sports, becomes 58. I hope this is clear. Okay. Let's move to the last two questions. What can be the minimum number of students who attended college coaching in exactly two sports? Okay. Now, guys, let's focus on this. We have already figured out that this 29, 30, and 31 is an acceptable combination. I'm not saying this is the only combination. We'll play around with these numbers now, but let's say this is an acceptable combination. Okay. What is asked? What can be the minimum number of students who attended coaching in exactly two sports? So I want minimum for this, right? How do I get that? I get that minimum. While this has to be minimum B plus D plus F, it has to be still greater than E, correct? So if I'm pushing B plus D plus F down, please try to visualize this with me. If I'm pushing B plus D plus F down, E is also getting pushed down with it by one value, correct? And the only way is if I'm shifting these numbers to A plus C plus G, which is my players playing exactly one sport, right? Because that goes up, only then the other two categories go down. Okay. All right. Let's see how much we can push it and how we can do this ahead. Okay. Understand this. So if I'm removing one player from E, if I'm doing -1 over here and putting it over A, C, and G, right? So there was a player who was playing all the three sports. Now that player is going and playing only one sport. So there are two sport instances which are getting reduced. Correct? Let me repeat. There was a player playing only three sports. And now if I put it to A, C, and G, the player will play only one sport. So two are getting reduced. Similarly, from here to here, there was a player who was playing two sports. And now if I'm shifting that player to A, C, and G, they play only one sport. So there is a -1 over here as well. Correct? All right. So I know essentially that every time I move this B plus D plus F one number down, there are three sports instances which are getting reduced. Okay. For the sake of this discussion, let's take this as 61, 59, and 58. Because these are the numbers that we have already figured out in the above two questions. Okay. So if three sports instances are getting reduced, right? Can I reduce three directly from this? No, I can't. Right? Can I do it from this? No. Can I do it from this? Yes, I can. But if I do all the three from only hockey, hockey will keep reducing and only one sport will keep increasing. And the number will meet sooner than I would like. Correct? So what I will do is, since I know three sports instances are getting reduced, I will distribute all these three among each of the three sports. Does that make sense? when I'm shifting two people from playing 3 sports and 2 sports, both of them to 1 sport, total 3 sport instances players are getting reduced. And if I want to maximize the people who are playing 1 sport, because only once I maximize that, I'll be able to minimize the people playing 2 sports, correct? But because we have a constraint that people playing only 1 sport has to be less than the hockey players, I can't just keep reducing these sports instances from hockey. I have to minimize that reduction as well. It's a little complicated. This was one of the toughest questions of the mock. Okay. So once I do that, once I remove these 3 instances, I will distribute the reduction in each of the 3 sports. 1, 1, 1. So let's say if I do this once, I'll make it 60, 58, 57. Right? And this single sport number will increase. And the 2 sport and 3 sport number will become 29 and 28 respectively. While this becomes 33. Correct? So what did we notice? When 2 sport and 3 sport reduced by 1, 1 sport increased by 2, and hockey reduced by 1. Yes. So I just have to keep doing this, or I can do it even mentally. Like if I have to reduce this by 9, this will increase by 18, and this will decrease by 9. Right? But then this becomes 49 and this becomes 49 as well. These two become 49. So that is not possible. So I can't reduce this by 9. I can reduce this maximum by 8. If I can reduce this by 8, this can be reduced by 8. Therefore, the minimum number of students who attended coaching in exactly 2 sports becomes 22. I hope this is clear. Just to revise and recap, if I'm reducing 2 and 3, 1 increases, but 1 has to be less than hockey. So I have to keep hockey as high as possible. So I reduce all the 3 sports together. Okay. And then I apply these constraints. So I get the answer to be 22. Last question. What is the maximum number of students who attended coaching for exactly 2 sports? Okay. Let's take this. Let's see what I can do with this. Similar logic. Let's say this is 29, right? This was 58 and 61. Okay. Now I want to maximize this. So if I have to increase BD and F now, AC and G will increase with it. And the only thing which will go down is the E, the number E, correct? So if these two have to increase together and this is the only one going down, E will go down with multiples of 2. Correct? I hope that is clear. Yes. So if E goes down to 27, this becomes 31 and 32. Correct? And so on and so forth. Now to attain the maximum number, E can go down by 28, thereby increasing this to this by 14 to 45 and 44. And this becomes 1. Right? That's the maximum. But if I do that, and this is for you to do at home, okay? If I distribute these numbers and see how these are affecting these 3 numbers, you will find that this constraint of hockey being greater than 1 gets violated. This is homework for you to do after this lecture. Please do that, okay? And let me know. And let me know in the comment section if you are able to do it. So I see that this will get violated. Therefore, I know that this can go down to minimum 3. This can be 43 and this can be 44, right? This is 16, 26, 13 and 13. Yes. So this becomes 43. So I hope this was clear. You need to try set number 2 with negative Venn approach and you need to see why this is getting violated in this specific question. But I hope negative Venn, identifying Venn diagram questions and a bit of minima maxima with the revision of our standard minima maxima framework is clear to all of you. I will see you in next lecture. Bye-bye.